Assalamualaikum. Let's learn about interference of reflected light in thin films. Light wave can reflect from objects at different medium and they will interfere with one another just like the light pass through double slits. So before this, we have learned about the Young double slit experiment. And from the double slits, the light waves will interfere at a point to produce dark or bright fringe. For these thin films, you will not use this screen to see the fringe, but you will use your eyes to see dark or bright colors. So what happens is, you will see bright bands of colors when light reflects from a soap bubble or from a thin layer of oil floating on water. These are the result of thin films interference. These are the example. This is the oil and also soap bubble. So the bright color is due to the constructive interference, while the dark color is due to the destructive interference. So the result of thin films is based on what you see from your eyes. So the two factors that you need to consider for the thin film interference, the first one is the optical path difference between two reflected rays. So when there are two reflected rays from the medium, you will see that there will be path difference. Second one, phase change due to the reflection on different type of media. If the reflected ray is from lower refractive index medium or less dense medium to a higher refractive index medium, there will be phase change occur, which is equal to pi radian 180 degrees, or we can say that the path difference is half of the wavelength. If the reflection is from higher refractive index medium or denser medium to lower refractive index of medium, there will be no phase change. So this phase change will determine whether the light rays is in phase coherent source or anti-phase coherent source. Now let's look at the first diagram. There are three medium: air, soap film and also glass. This incident light or ray 1 will incident on this surface. Some of the light will refract into the soap film, while some of the light will reflected from it to produce reflected ray 2. And the light that refracts into the soap film will then refract into glass, while some of the light will reflected or it will be ray 3. So what will happen is the light wave from ray 2 will interfere with light ray from ray 3 at a point, then will undergo constructive and destructive interference. So you will see either bright color or dark color, depends on constructive or destructive interference. Now let's look at the phase change. How to know whether other phase change or not? If the reflected ray is from or is due to the reflection from less dense to higher dense surface, thus it will have the phase change. Okay, so contoh yang ni, ray 2 ni reflected daripada air into the soap film and has phase change. For ray 3 is reflected from soap film to glass, so daripada less dense to higher dense medium, so it has phase change. When both of these two reflected rays has the phase change, thus we can say that dia adalah in phase coherent source. Okay. Second diagram, here we have medium air, soap film and also air. The incident light or ray 1 will incident on this surface. Some of the light will refracted into soap film. Some of it will reflected into air. And there is phase change right here because this reflected ray 2 is from less dense medium to a higher dense medium. Then the refracted ray that enters this soap film will then reflected to produce ray 3, and there will be no phase change. You need actually to refer to this point. No phase change because this reflected ray 3 is from soap film to air, daripada denser to less dense medium, so no phase change. If salah satu of this reflected ray no phase change, there's these two source we call as anti-phase coherent source. Now, what is in-phase coherent source? So, in-phase coherent source will have the result of constructive or destructive interference. So, if you see bright color from the interference, so maksudnya daripada constructive interference. Kalau you nampak dark color, so itu adalah destructive interference. So, they will have their own equation later. So, apa yang kita nak cari sebenarnya daripada this experiment? We want to find the thickness T right here. Thickness of the thin films. So, a monochromatic light, ray 1, incidence almost normally onto a thin soap film of thickness T and refractive index N. So, refractive index ni refers to the thin film. Ray 1 is reflected partially by the upper side of the thin film, produce the first reflected ray, which is ray 2. Part of the light enters the film, which is this refracted ray, and partially reflected by the lower surface of the thin film to produce second reflected ray, ataupun kita panggil sebagai ray 3. So, ray 3, kita akan nampak dia travels at extra distance of PD, path difference, equal to 2nt in thin film before these both reflected rays recombine in the air of the above surface and interfere. So, katakanlah ini adalah light wave for ray 2 and light wave from ray 3. So, they will interfere, akan combine, sama ada constructive ataupun destructive interference. So, as both ray 2 and ray 3 ni reflected from less dense to higher dense medium, so they will have phase change. Bila dua-dua ni berlaku phase change, maka kita katakan sebagai they act as in-phase coherent source. So, the equation for constructive interference to NT equal to m lambda. N is the refractive index of the thin film. T is the thickness of that film. M is the order number. So, kalau untuk bright, M equal to 1. Kalau untuk dark, M equal to 0. So, for dark, the equation is 2nt equal to M plus half lambda. So, what you need to do is, when you get this kind of equation, check whether they are in-phase or anti-phase coherent source. Then baru you determine which equation that you want to use, and then check which is the order number that you are going to substitute. Next is anti-phase coherent source. So, nak check whether it is in-phase or anti-phase, check these two reflected ray 2 and ray 3. Ray 2 is reflected due to from the less dense medium to higher dense medium, so ada phase change. Ray 3 is reflected from the higher refractive index to lower refractive index, so there is no phase change. Check dekat sini ya. Okay, daripada soap film to air, so tak ada phase change. When one of the reflected ray has no phase change, so they will act as anti-phase coherent source. The equation for constructive interference is 2nt equal to m plus half lambda, or the interference will appear bright. So, you can nampaklah bright color. For the destructive interference, the equation is 2nt equal to m lambda, and it will appear dark. For the m used for bright, substitute m equal to 0 and dark equal to 1. Kenapa 0 dengan 1 sahaja? Kenapa tak ada 2, 3 and 4? Because we want to find the minimum thickness, yang paling nipis sekali. Okay, minimum thickness. So, we need to use the lowest value, sama ada 0 ataupun 1. So, untuk constructive interference, the lowest value that we can substitute is 0. While for destructive interference ni, equation ni, we can't substitute 0 sebab nanti T equal to 0. Tak boleh. Okay, so untuk dapatkan the value of minimum thickness T, we need to substitute the lowest value that we can get T, which is 1. Let's do example 2.4. Nearly normal incident white light falls onto a glass block whose surface is coated with a thin, uniform, transparent film. Incident ray, ray 1. Nearly normal maksudnya dia punya incident ray ni hampir mendekati normal line right here. Yang ni adalah normal line, which is always 90 degrees with the surface. The surface is coated with thin uniform transparent film. So let's say kita ada glass block dan kita ada thin film kat sini. Contohnya macam tinted film. Itulah contoh thin film lah. That can coated this glass block. The refractive index of the thin film is 1.38 while the glass block is 1.52. Determine the minimum thickness of the thin film which could reduce reflection of light of wavelength 500 Newton meter. Reduce reflection maksudnya destructive interference. So kalau kita tengok permukaan thin film tu, kita akan nampak gelap. Okay, sebab dia reduce reflection. Okay, what happen when this ray 1 enters this thin film? It will refract into it while some of the light will reflected from it to produce ray 2. Then you check whether this ray 2 has phase change or not. It reflects from the less dense to denser medium, thus it has phase change. Meanwhile, at this point, when the ray 3 reflect, it is from less dense to a denser medium. So yes, it also have the phase change. So bila dua-dua reflected ray 2 and ray 3 ni ada phase change, thus they will act as in phase coherent source. Determine the minimum thickness of the film T which could reduce reflection of light. So ni maksudnya kita nak tengok bahagian dark. So the equation for destructive interference for in-phase coherent source is 2nt equal to m plus half lambda. 2n is the refractive index of the thin film at the center. 1.38 thickness kita nak cari. M, if you want to look at the dark side, then substitute m equal to 0 plus half times with the wavelength which is 500 nanometer. And the thickness of this thin film is 9.06 times 10 to the power of negative 8 meter. Or you can also write it as 90.68 nanometer. Example 2.5. Light from a sodium lamp with a wavelength of 598.3 nanometer is incident on a soap film if the film has an index of refraction n equal to 1.4 and is suspended in air n equal to 1. Find the minimum thickness of the film which appears dark in reflected light. So appears dark ni maksudnya kita nak tengok destructive interference. So based on this figure, we have 3 layers of medium. The first one is air, second one is soap as the thin film, and the third one is air again. So dia macam seolah-olah macam soap bubble lah. Okay, so what happened is ray 1, the incident ray 1 will refracted into this thin film and some of it will reflected as ray 2. So check ada phase change ataupun tak. Ray 2 reflected from less dense to denser medium, so yes, ada phase change. And this refracted light ray will reflected again to produce ray 3. And this ray 3, there will be no phase change right here because it from denser to less dense medium, so no phase change. If one of the reflected ray does not have phase change, thus they will act as anti-phase coherent source. So for anti-phase coherent source, ada dua equation untuk bright and dark. If you want to find the appears dark or destructive interference, so the condition for destructive interference for anti-phase coherent source is 2nt equal to m lambda. So 2 is 2, n is the refractive index of the soap which is 1.4, t equal to m will be equal to 1 times with the wavelength 598.3 nanometer. The minimum thickness of the soap thin film is 2.14 times 10 to the power of -7 meter.